Assalamu alaikum. Welcome to VLSI lab. Today we will discuss regarding how to design a buffer using DSCH as well as Microwind. At first we will design a buffer circuit using DSCH. Then we will transfer the circuit to Microwind. Then we will show how to reduce this circuit by using Microwind solely without transferring the verilog file. So let's begin. So basically, as we know, a buffer circuit is nothing but a combination of two NOT gate. Um, uh, we can also consider it just a buffer gate. So at first, in our previous videos, we designed CMOS inverter, which is equivalent to a NOT gate. So in this video, we'll show how we can design buffer using two CMOS. If we use two CMOS, then for one, if the input is 1, then the output will be 0 in first CMOS. For second CMOS, we will use the output of first CMOS as input. In that case, in this case, it is 0, then we will get the output 1. So for input 1, here we get the output 1. That is why it is called buffer. So you may think that why we have to use buffer circuit. We need to use buffer circuit because in order to synchronize the operation of two devices, mainly we used buffer circuit. Besides, to create time delay, we used buffer circuit. So let's begin. At first, we'll design this circuit using DSCS. So let's move to DSCS. So this is our well-known DSCS window. So let us see what we need to do. At first, we need to place two PMOS and two NMOS. Then we need to provide the connections as per this connection diagram. Here we see a button is used as input, and the output for watching the output, a lamp is used. Besides, we need to provide the supplies and as well as ground connections, VDD and ground connections. So uh, let's move to the window, DSS window. So at first we need to place two PMOS and two NMOS. So here is the NMOS and PMOS. As we know, PMOS are generally placed in pull up network, and NMOS are placed in pull down network. So we need to drag and drop the MOS here. So these are the two PMOS, and we need to drag two NMOSs as pull down network. To create the pull down network, we'll draw drag two NMOSs. Okay, it will be better if we placed in just parallel position so that we can easily connect them. So let us move to the circuit again. Here we see at first we need to short circuit the gate. As we know, our input is only one input will provide it, and we also need to short circuit the gate of the two PMOS, PMOS and NMOS here, as we need to use the output of first CMOS as the input of another CMOS. So we also need to connect the source of two PMOSs as well as source of two NMOSs. So let us do it. We can connect it by using add a line. So simple. So use add a line and connect. We need to connect the gate of the PMOS with NMOS, then the drain of PMOS with NMOS, and also the same for these two PMOS and NMOS. After that, we need to give the output of provide the output of one CMOS to the another, one CMOS to the another CMOS, and we need to collect the output from the drain of this CMOS. So basically, we already designed our record circuit. Then what we are missing here are the inputs and outputs and the supply and the ground. So let us provide input. Here we use button as input. So button is here, lamp as output. So to see the output, so lamp is here. Then we need to provide the ground. So this is ground, and also the supply. So supply is here, BTD supply. Then our task is very simple now. Just we need to save it. You can just click save for saving the file. You can also use save as option. So click save as and use buffer circuit, buffer circuit, and just save it. Okay, we can also now we can check the connections if we feel that our connection is not okay. Here we see we used a button as input. Basically, we should not use it. So for this, we have to use gun, and by using gun, we can easily cut it. So after cutting it, we need to use a clock as input. So we take clock as input. Hopefully other connections are okay. So here we placed a clock as input, and output is taken from the drain of the both MOSFETs, and again this output is provided as input to the gate of both MOSFETs, and finally the output is taken from the drain of both MOSFETs. So let us simulate it. Here we see the actions, how it's happening. Basically, you can slow down the simulation process by using this so here we see the operation is very clear. When the input is low, output is low. After a certain period of time, if input is high, the output is high. So here we see clearly that for zero input, we are getting zero output. For one input, we are getting one output. We can watch this in the timing diagram. So this is the timing diagram. Here we see as the input is 0, output is 0. As the input is high, output is high. So for low input, output is low. For high input, output is high. So this is the basic buffer circuit using CMOS. So after that, we can generate the verilog file. So as we know, in file options, the verilog generating process is available. Just click on make verilog file and just click OK. So this file is created and save as buffer circuit.txt in DSCH. So our next operation is that we need to go to Microwind and open this verilog file. So let us go to Microwind. So in D drive here I kept microwind already. So microwind. So this is the wind window, as we already know. So here we need to go to compile option and compile verilog file. So here is the DSCH. Here only shows the verilog.b file. If we select all files or text files, then our files will be available. We select all files. So the buffer circuit.txt file is available. Just click on it and open. Just compile. Back to editor. So this is the layout of the buffer circuit we have designed. Here we see so many PMOSs and MOSs are connected together, and the connection is very complicated. Here we find 1, 2, 3, 4, 4, 5, 6, 6 PMOSs, 2 NMOSs, and other connections. Those are very complicated. So we can easily reduce this circuit to a simple circuit in Microwind. So let us do it. So for this, we need to open a new window here. Save. Okay. So this is the new window available here. So what we need to do is that we need to design the circuit following this figure. This is basically two CMOS layouts are connected together to get the buffer circuit. So let us move to Microwind. So here what we need to put. Let us at first we need to discuss this circuit. Here we see two PMOSs here, and in this two PMOSs, as we know, we need to provide the excitation. So at first we need to provide the excitation in annual of the PMOSs. These are BDD supplies. After that, we need to connect the semi polysilicon of PMOS with NMOSs, polysilicon of PMOS with NMOSs, and then we need to connect the metal with polysilicons. And after that, we also need to connect the metal of the PMOSs, two PMOSs together, and the metal of the two NMOSs together. After that, we need to provide the input and output. So these are our basic tasks. So let us move to Microwind. So this is our micro window. Here we are missing the palette, so we can easily create this palette by click on here. Here we need to generate the PMOSs and NMOSs. For this, we need to use this MOS generator. Here we see the MOS generator, and there are both NMOS, PMOSs. So at first, we like to basically I like to generate PMOS. So click on PMOS and generate device. Here it will generate. You need to click on this window to get this file. Just click on this window here. I click on this window and get the file. Again, click on this window for again we need another PMOSs. So again we need to select this and generate device and just click on this window. So two PMOSs are already generated, but one PMOS is just out of our window. Just for this we need what we need to do is that we need to select a scratch and move, then just select it and move it. So I like to move it here. Similarly, this one here. So these are two PMOSs. After that, we need to generate two NMOSs. So click on here and generate devices. Just click on here. This is the NMOS, and we need to generate another NMOS. Just generate device and click on here. It is very important to maintain this PMOS and NMOS in parallel position, this PMOS and NMOS in parallel position, straight position, because we need to connect the silicon of this PMOS with this NMOS and as well as this PMOS with this NMOS. So if we look at the circuit, we will see it. Here we see we need to connect the silicon of this PMOSes together, polysilicon of this PMOSes together, metal of this PMOSes, PMOS and NMOS together, metal of this PMOS and NMOS together. So we need to move and stretch it. Just select move and stretch. Select it. Here you go. So next task is to provide the acceleration in NMOS, PMOS and well. For this we need to provide BDD supply. Here is the BDD supply. So we need to provide this one here and this one here. So two BDD supplies are given in the N well of the PMOSes. Then we need to connect the polysilicon. We have to connect the polysilicon. Here you see the polysilicon. Select poly, just select poly and connect it. Okay, it's not so difficult. Just easiest way of connecting to polysilicon. Here we see we can easily connect it. Similarly, we need to connect the polysilicon of these MOSes with this MOS, and for this again take polysilicon, select poly and just draw the polysilicon line for connecting. Here you see it's not perfectly placed, so we can we need to slightly move this PMOS. For this we need to use stretch and move. Hopefully it's now placed accurately. If not, we can easily move it in similar way. So select polysilicon here again and try to connect it. Here you see this time these two PMOSes are PMOS and NMOS. These two MOS are perfectly straight position, so that we can easily connect the polysilicon of PMOS with NMOS. So after that, our task is very simple. We need to connect the metal of PMOS with NMOS. So here we see we need to select metal one. After that, just connect the metal one with metal of PMOS with metal of NMOS. Similarly, select metal one, connect the metal of PMOS with the metal of NMOS. So that's so simple. Here we also need to connect the metals here. So let us check. So the metals is also connect in these 2 points and in these 2 points too. So let us do it. At first we need to select the metal and just need to extend this portion. After that, just need to connect these two. Similarly, in the bottom end, we need to do the so for NMOSes. So our connection is almost completed. If we look at it, then here is the important connection, that is the connection of metal with polysilicon is still to be completed. So here we see the connection of metal with polysilicon. So to do so, select metal here. At first, we would like to extend the polysilicon line. So we can easily extend the polysilicon line. So here you go, extend the polysilicon line and select metal. Just connect it. So we connect the metal with polysilicon, but the connection is not established yet. Why? This is because these two materials are separate material, different material. So for connecting two different material, we need to use a connector here. So this connector are available. Contact between metal and polysilicon, we need to use this connector to create the contact between metal and polysilicon. Here are some other options: contact and diffusion, contact P plus diffusion and metal, contact metal 1 with metal 2, contact metal with metal 2. So these are some options available here. So we need to pick this one, metal and polysilicon, and just drop it here. So the connection is established easily. After that, let us check the connections. So here we see we almost completed all the connections except the supply, BDD and BSS, as well as the input and output. So let us complete these steps. At first, I like to complete the easiest step. This is, and these are just provide the supplies. So here we see the BDD supply. Just select it, drag it here, select and drop here. Then BSS supply, that is the ground supply here. So BDD and BSS supply is already provided. After that, we need to provide the input and output. So our input, we use this clock as an input. Add a clock here available. Similarly, here is add a pulse is available. Don't make a mess between these two. We need to use add a clock as input. So input is here. Just we can rename it as input and assign. Here we see some slower, faster options are available. We don't need to think so much regarding this. Just we need to assign it. And visible in simulation, it will be visible in simulation. We can not in, you can make it not visible in simulation, invisible in simulation, but we like to make it visible in simulation. So assign. So here is the input, and after that we need to take the output. So let us see the point where we will take the output. We will take the output from this metal point. So that is, this is basically the drain point, common drain. So for this, we need to look at the output. For looking output, we use usually the visible node, the I symbol. Just put it here, and this is our output. Okay, just out. Similarly, make it visible in simulation. You can make it invisible, not invisible in simulation. So make it visible and assign. So our circuit is completed. Hopefully, we did it exactly as per our requirement. We can also check it, by analyzing this circuits. Here we see the input, outputs, how it's connected. Two PMOSs are there, two NMOSs are there, BSS is there, BDDs is there, and the metal of this drain point is connected to the semicon polysilicon points. The output is taken. BDD acceleration is earlier provided earlier. So hopefully the connection is okay. If it's not okay, then the simulation will not run and we'll see the error. So it's better to run the simulation and check whether the connection is okay or not. So you can also check it before simulation by using design rule checker. You can use it, and this rule is so no design rule errors. Congratulations. So here we already find the congratulations. That means that our design is okay. Basically, now we need to save this design. Just use save as. You can also save it directly. Buffer circuit or CMOS buffer. Save it, and after that our task is very simple. Just run it. You know this very known famous run simulation icon. Just click on it. Here is the simulation. We can time scale it to analyze the result better. So here it is. As you see, for buffer, for zero input or low input, output is low. For high input, output is high. So here we see in each and every step, when input is low, output is low. When input is high, output is high. So this is how we can design a buffer circuit using DSCH and Microwind. We can also analyze these circuits in different ways. We can see the cross section of this circuit. Just click on in this way. You can see the metal position, thickness, height, width in this position. We can also see the 3D fabrication steps here. Just what we need to do is just need to see the next step. So how it will be fabricated. These steps are described in right hand side. These are the steps by steps process in 3D format. We can see each and every steps here. So this is how we can easily design the CMOS buffer. Hopefully you enjoy it. Thank you. Stay connected. Assalamu alaikum.